We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes. But it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own, and our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system, but these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth, and it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. L9859c, and it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy, so it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live, but because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising, L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where that water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L98 Tau 59. It's a rocky planet, 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet EF in this star system, located right in this sweet spot. This super-Earth candidate, L9859f, is 2.5 times heavier than our home planet, so we have hopes that it's a rocky world, just like the other planets in this star system. The way to planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there is a slight drop in the star's brightness, that's when a planet has passed between us and the star. Like this dot, we have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,115 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk, and they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts, but it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signal too, but so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super habitable. So, some scientists think that Earth is a good place for life, but not the best. Super habitable planets would have to be 30% larger than Earth, and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This, in turn, would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This will make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star, and voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them. Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangaea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, Its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving, just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other, or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth, like the Himalayas, formed because tectonic plates were pushing into each other. Now, here's the thing with Pangaea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So, if Pangaea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangaea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please, feel free to build up in intensity without anything to bump into. So, once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in eastern Pangaea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. If Pangaea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert, but there would also be dense cool rainforests along the borders of this desert. Why? Because Pangaea is so massive, and rain from the ocean wouldn't reach far enough inland, so it will be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangaea might even shrink and disappear underwater. Closer to the edges of Pangaea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons. But we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangaea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangaea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands, like Madagascar and Australia, mean less cool and unique plants and animals. The climate problem doesn't either. Almost all Pangaea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So, basically, Pangaea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north. and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news. All our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries could have completely different boundaries, and the world could be much more see. First, we'd form some tribes, but since we would share the land, we'd have to compromise. We can't all have only the coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly, except for the ones we could potentially domesticate. Imagine having dinosaurs as pets, but the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier to do. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangaea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay colder. So, even though some people would still have white skin and blonde hair, in general, everyone would have less melanin. Around the central part, where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm, the crops are growing well, the neighbors are, hopefully, peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we'd learn to treat each other with more kindness and love. But we can only imagine. For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP899b and LP8909c. Buckle up, because we're heading to LP899. A red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP899b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP899b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9C. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP890-9B. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now, this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on, it's not all sunshine and rainbows for LP890-9C. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate, and Venus isn't known for being human-friendly. But despite these challenges, LP890-9C is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists led by researchers at the Instituto de Astrofísica de Canarias has found two Earth-like planets, just 16 light-years from our own solar system. They both orbit a red dwarf star called GJ1002. Our sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning that they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but you know. And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, is located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet, just like Earth, and if it really does contain water, there could be even life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like, or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP890-9C. That would be unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star, and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great. Finally, at least somewhere winter and summer will flow normally. Kepler 1638b could also have some liquid water there. That's why it's also a good candidate for further study to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth, and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions? Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many, many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But, unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then, they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So, what is this cold spot and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1, cosmic texture. This idea was brought up at the end of 2007. Then, scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2, the supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one. Perhaps the most bizarre of them all. Theory 3, a parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it had become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes, but we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line where surface temperatures are freezing. But they later migrated closer in to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious. It's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just haha. We've named it TOI 2182b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees. For comparison, the temperature on Jupiter and Saturn is around 280 degrees. It's like a bridge between the giant exoplanets we found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we'll get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the Planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1,122 0. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog. Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These giant gas planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot, blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called hot Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown to the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron, and yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery and a puzzle that we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The football planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter, it's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. The team of researchers analyzed 47 potentially habitable exoplanets named Kepler-69c, Kepler-1229b, and Kepler-395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1256b, not a home video recording system, but a strange and exotic world, shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter. But it's not quite a star. It's something in between. A cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet. And it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our own world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets, but this is just the beginning. As scientists and researchers continue to explore the vast expanse of space, we can only imagine what other wonders await us. So, let's keep looking up. Who knows what secrets the stars hold for us next? Ah, well-deserved vacay. Finally. This time, you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus moon's oceans, let's talk about Uranus itself first. The seventh planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet, and that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups, 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my! These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too, and because of that tilt, they have crazy seasonal cycles, just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit? They're likely captured asteroids that could be rocky or icy or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon, with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half ice, half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons, with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features. But one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces. And the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now, you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited, these oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, well, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe. UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore. Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon, and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins, and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're gonna make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades, and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon, using data previously collected by NASA, and what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.5 kilometers closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home. So it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits. So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers: 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while, but its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger, depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say, 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected, but if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers, if that's really the case. Then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs, our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand: the wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical. When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers, vanishing and appearing sources during a century of observations, VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be the data was wrong, or these stars were too faint to detect? Nope. They quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reach the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life. So it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit they're cool, though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts, FRBs, are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or a black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too, and the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see, but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity? We're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars, and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas. A huge asteroid, several hundred feet across, is dashing toward Earth through the black nothingness of the cosmos. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting us. Now, you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The latest one occurred in April. 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then, they work through all the tricky questions they can come up with, like how big is it, where might it hit, what should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are the folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. If an asteroid really was aiming at Earth, it wouldn't just be one country's problem, it'd be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside US agencies like NASA's Planetary Defense Coordination Office and FEMA to figure out how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. The big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we would be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 1 meter wide entered Earth's atmosphere and, luckily, burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid 2024 BX1 turned into a blazing bright fireball visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site about 60 kilometers west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Another example, a small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 71 centimeters across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid, Sidub Websave, entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there were no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 30 meters wide. It flew by Earth recently on July 9th, passing us at 50 million kilometers. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 km/h. It's 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid 2015 XF261. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this kind of mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 32 million kilometers of Earth. In April 2028, it'll get even closer. By that, I mean 21 million kilometers away. A year later, in April 2029, the asteroid will end up just 6.7 million kilometers away, making it the best shot for a mission. Another decent chance will be in April 2030. That's when the asteroid will pass our planet at 7 million kilometers. To give you some context, NASA's DART mission once targeted an asteroid 11 million kilometers away, and the trip took 10 months. So, China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, 2019 VL5, which is also about 30 meters wide. It's not clear why they switched to the current one, 2015 XF261, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So, the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendelev's periodic table of the elements, or those funky snacks you buy. Look at this exoplanet called K218b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things, floating around in space, but not orbiting around any star or brown dwarf. Instead of our Sun, K218b orbits a red dwarf called K218. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K218b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 31 trillion kilometers. You do the math. Hint, lots of zeros. K218b is a sub-Neptune, meaning it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K218b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth, and has an equilibrium temperature of 2 degrees Celsius. Nope, it doesn't mean that K218b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Trillions of miles that set us apart aren't a problem for potent telescopes such as the Kepler Space Telescope that discovered this planet, and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they found water vapor in the atmosphere of exoplanet K218b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check, and plants love the stuff too because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it, without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K218b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide, or simply DMS, in the mix. On Earth, this stuff is usually linked to life since it's normally produced by phytoplankton in the oceans. The fact that we're picking up hints of DMS on K218b is like finding a golden ticket in a cosmic chocolate bar. Kind of gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean with a hydrogen-rich atmosphere, resembling a gas giant like Uranus or Neptune. This one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water ocean thing is up in the air. Initially, we thought water in a supercritical state was more likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini-Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found out that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and it's probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with a temperature inversion causing a stratosphere situation. Just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet. Unless the planet is spinning super fast, and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from its star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's hard to tell if there's life on K2-18b because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations. You're one out of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one in almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe that itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely there must be some other habitable planet. Here's where the Fermi paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allowed scientists to discover over 5,000 planets outside our solar system, yet still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi paradox. These outer world beings may just be too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rockets would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. We could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet, not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for everybody else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope, and this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet, the same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant in a hibernation status, and they may be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form, but those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution, and this may be a potential future for us too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. If it can happen to us, who's to say it didn't happen to other species in the past, on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe, forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi paradox has a name though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide and seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, destroying them first could be our only hope. So, if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups become friends but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivety. The dark forest theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claimed the news is fake, others tried to understand the reality that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light years of us might be getting our signals, and if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades away, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water, there is no life, at least not as we know it. It begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe: carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other types of creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think: Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model. History teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word, Panagia, which means all the Earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakup party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Just look at the shapes of today's continents. You notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by water for years. But even so, we still can see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they noticed something interesting. These fossils looked similar. Surprisingly, they belonged to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their 4 paws, and it's unlikely that this particular type of animal originated in 2 places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at all these things together, you get a pretty clear picture. The Earth's continents were once huddled up together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were 2 original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figured out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangaea, Pangaea Ultima, Arica, and Amasia. These might sound like superhero names, but they're actually different ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up, while the Pacific squeezes in. If that happens, the Americas, North America, and South America will give each other a big high five, and Antarctica, that icy land way down south, will join the fun too. It will be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading and spreading all along the east coasts of the Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas. And boom, Orica. And finally, a Masia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents, except Antarctica, might come together. And even though they might gather around the North Pole, they wouldn't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo-Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. Keep asking curious questions and stay tuned for the next 100 million years. Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how bright or big it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories has been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis, Earth spins around and extended it for over 300 light-years past the North Pole. At the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day, we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point toward the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it will regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old solar system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 38-centimeters refractor, and it happened in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. In the vast expanse of the universe, there are planets unlike any we've seen before. Planets with a treasure trove of diamonds. What mysteries do these sparkling worlds hold? What do they look like? And most importantly, just how much would it all cost? Let's find out. First of all, let's take a look at diamonds in general. We see them as rare and valuable gems. But did you know that they actually come from something as ordinary as carbon? That's right. This is the same element that's found in your pencil lead, or coal. This is also the key ingredient in a diamond. But how does a plain old carbon atom turn into a dazzling diamond? Well, it all starts deep beneath the Earth's surface. At depths of around 100 miles, carbon is exposed to temperatures of over 2,000 degrees Celsius and pressures over 825,000 pounds per square inch. That's like putting the weight of 3 elephants on a postage stamp. Under these extreme conditions, the carbon atoms bond together in a unique way. They form the crystal lattice structure that gives diamonds their distinctive shape. This process can take millions or even billions of years, as the carbon slowly makes its way closer to the Earth's surface through volcanic activity. And then, finally, the diamond is formed. After that, it may stay hidden in the Earth for thousands of years, until it's brought to the surface through volcanic eruptions. From there, the rough diamond is cut and polished into the beautiful gems that we know and love. So why are diamonds so valuable? Well, it's partly because of their rarity. Only a small fraction of the diamonds that are formed actually make it to the surface. But it's also because of their beauty and durability. Diamonds are the hardest substance known to humans, and they have a unique ability to refract light in a way that makes them sparkle and shine. Diamonds also have a wide range of practical applications. They're used in cutting tools, grinding wheels, and even in the tips of surgical instruments. And thanks to advances in technology, scientists are finding new ways to use diamonds in fields like electronics, energy storage, and medicine. All this goes to show that sometimes the most extraordinary things can come from the most ordinary of elements. Now that we know this, let's get back to our diamond planet. Can planets like this even exist? Actually, yes, they can. In fact, we come across diamonds in space much more often than on Earth. In space, extreme pressure and temperatures are very common. That's why the universe, and even our solar system, is actually incredibly wealthy. Your regular asteroid can cost millions of dollars. Helium, which we can find almost everywhere in space, has a huge energy potential. It's not surprising that humanity has been discussing the possibility of space mining for some time. Now, as I mentioned earlier, diamonds are formed deep within the Earth under conditions of extreme heat and pressure. Scientists believe that a similar process could occur on a planet that's rich in carbon. There are a few possible ways it could happen. For example, when two planets or asteroids that contain a lot of carbon collide with each other, the collision would create a shock wave that would push the carbon atoms together so tightly that they would form a diamond. The second way it could happen is if this region of space contains a lot of carbon. If the conditions are right, then the carbon atoms could come together and form a planet-sized diamond. It's like if you have a lot of Lego blocks and you put them together to create a big Lego structure. In other words, if two carbon-rich objects collide with each other, the carbon atoms can be squeezed together so tightly that they form a diamond. And now, surprise, surprise, these planets actually do exist. The planet we're talking about is called 55 Cancri E. It's one of the 5 planets in a small system in the constellation of Cancer. Its star is actually so bright that you can see it with the naked eye. It's located 40 light years away from us, which may be trillions of miles, but on a space scale, it's pretty close. 55 Cancri E was first discovered in 2004. However, we didn't learn until 2012 that it was the first known diamond planet. All thanks to the research of scientists from Yale University. This planet is the super-Earth. This is a class of planets that are larger than our Earth but too small to be considered giants. It's about twice as big as our Earth and about 8 times heavier. The planet rotates around its star really fast. It completes a full turn in just 18 hours. This means that 1 year on the planet is less than a day on Earth. It's also tidally locked to the star. In other words, one side of this planet is always turned towards the star, and therefore is incredibly hot, while the other is in eternal darkness, just like with our moon. Also, 55 Cancri E is about 25 times closer to its star than Mercury is to our sun. As a result, the temperatures there are just enormous. On the day side, they're just above 4,000 Celsius, and on the night side, which by the way is considered the cold one, over 2,500 degrees. Doesn't really sound like a good place to chill out, does it? Well, it may not be good for us, but for diamonds, it's just perfect. After studying the planet, scientists concluded that it's a rocky world full of carbon. But this carbon isn't contained there in the form of gas. Instead, it's in the form of graphite. Yes, the same one found in your pencils, and of course, diamonds. According to some estimates, diamonds make up at least a third of 55 Cancri A. It can cost about $27 nonillion. There are 30 zeros in this number. Can you imagine that? But the most interesting question is, what would such a planet look like? First of all, the thermal evolution and tectonic processes there are completely different compared to our Earth. In other words, the planet should be full of strange volcanoes and some bizarre volcanic activity.
Weird mountains and stuff like that. In addition, the planet is probably covered with large clouds of dust, and the atmosphere on it is very dense. And the weather there is definitely crazy.
The researchers are planning to learn about the composition of 55 Cancri E's atmosphere in the future. But right now, it's already pretty clear that this planet can't be called habitable. Well, finding life there is theoretically possible, but it's very unlikely. Life on a diamond planet could potentially exist deep underground, for example. On Earth, we've already observed bacteria and microbes that can survive under incredibly extreme conditions. These guys are very resilient. They're capable of turning chemicals into energy and surviving basically anywhere. So, on a diamond planet, life could potentially exist in this form. And who knows, extraterrestrial life may also take forms that are completely unknown to us. Wouldn't it be cool to discover some crystal creatures capable of surviving in the most extreme heat? That would be mind-blowing.
And guess what? It's not just 55 Cancri E that's full of diamonds. Other potential diamond hotspots include Pluto's largest moon, Charon, and a Jupiter-style exoplanet rich in carbon, found 1,200 light-years from Earth called WASP-12b. Scientists even think that diamonds rain on Saturn and Jupiter regularly.
All this was discovered by the researchers from the Arizona State University. They claim that diamond planets are not that rare at all. According to a 2020 scientific report, they form around certain types of stars that have high carbon-to-oxygen ratios. They went above and beyond to study these space gems. They subjected carbide silicon to insanely extreme pressures above 50 GPa and temperatures as high as 2,500 degrees Kelvin to see what would happen. And they discovered that under these wild conditions, carbide silicon transforms into diamond and silica. So, if you're looking for some diamond bling, you might not have to go too far. You could go intergalactic and explore some of these diamond planets. These exoplanets are unlike anything in our solar system. And who knows what other awesome discoveries are out there waiting for us to find them. There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like Earth, the moon is made of layers: a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity, but it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing mineral. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything, from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years. That's some million-dollar questions. The moon's core generates heat, just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. First, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general, speaking temperatures of course. With temperatures dropping to 128.9 degrees Celsius on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh. Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. That's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty, hollow tunnel, hence a lava tube. On Earth, we see lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, a place where Apollo 11 first landed, and it's at least 103.6 meters deep, and all these cave systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden beneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. The best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 17.22 degrees Celsius. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So, humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure, there's a huge potential for exploring these caves and finding some awesome stuff, but even if we manage to find a miracle like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves for a future base, showing that the race to explore and settle the moon is heating up. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it has had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries despite some initial technical difficulties. In 1993, a problem in the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the most interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We do know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers are not sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager. I also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light though. It is like the glow from 10 fireflies, but it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps showed that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helped scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happened in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. They are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense, hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape their pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It has also noticed a strong connection between the sizes of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than the Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Before Hubble, we didn't really know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age. About 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then. Well, it turns out black holes might not be as elusive as we once thought. They might be hiding within stars. In this case, the extra mass of some of these space lanterns could explain weird gravitational effects in the universe. Previously, dark matter was the cause of these phenomena. The black holes I'm talking about might be those itty-bitty ones that appeared at the dawn of time when the universe was just a baby, and they may still be lurking in the hearts of giant stars. A team of scientists say the idea might be quite plausible. Astronomers could detect such trapped black holes by the vibrations they produce on their stars' surfaces. And if there are many of them out there in the cosmos, they might function as the very dark matter that holds the universe together. Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close. Usually, space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. In 1971, renowned physicist Stephen Hawking suggested another origin of black holes. If we took the thick soup of particles that appeared moments after the Big Bang and the birth of the universe, we'd be bound to find some spots dense enough to collapse and create black holes. Such holes, which got the name of primordial black holes, could range in size from microscopic to gigantic. If they were pervasive and numerous enough, primordial black holes could act as dark matter, knitting the cosmos together with their enormous gravity. And dark matter is believed to make up 85% of all the matter in the universe. So what's the matter? Astronomers have been searching for primordial holes by looking for flashes that would occur when they pass in front of distant bright objects, magnifying their light like a lens. But they haven't spotted even one yet. On the other hand, if a primordial black hole was tiny enough, with a mass like that of an asteroid and a diameter as minuscule as a hydrogen atom, the flashes wouldn't be bright enough to be detected by such surveys. Then, the team researching the phenomenon of primordial black holes decided to consider the consequences of a universe where dark matter was made entirely out of tiny black holes. They concluded that one of such teensy holes could be dashing through the solar system at any given time. Some might occasionally get trapped within gas clouds, giving birth to new stars, ending up in their centers. The next step of the researchers was to build a model of a black hole existing in the very core of a star where hydrogen atoms undergo fusion and produce light and heat. At first, they didn't see anything unusual. Even a super dense stellar core is mostly empty space, and it wouldn't be easy for a microscopic black hole to find matter to consume there. That's why its growth would be incredibly slow. It could take longer than the lifetime of the universe for this tiny hole to eat a star. But what if a larger hole, as massive as the dwarf planet Pluto or asteroid Ceres, appeared at the center of a star? Then, it would get bigger in a matter of a few 100 million years. The material would keep spiraling into the black hole, creating a disk that would heat up because of friction, emitting radiation. Once the black hole grew to the size of Earth, it would start emitting even more radiation, shining extremely brightly. It would also be churning up the star's core, and the star itself would turn into a black hole-powered rather than a fusion-powered object. Such entities were dubbed Hawking stars. To cool off, the exterior of a Hawking star would form a red giant. That's what our sun is likely to turn into as it gets older. But a red giant star with a primordial black hole at its center would be cooler than the star that has reached this stage through regular means. Such stars are known as red stragglers. To find out whether they indeed host a black hole, astronomers might need to tune in to the frequencies at which stars vibrate. Since a Hawking star would mostly affect the interior of the star rather than its topmost layers, the star would thrum with a certain combination of frequencies. The waves created in the process could be detected in the way the star's light would pulse and throb. So, all scientists need to do now is to study the already known red stragglers and figure out whether any of them show the characteristic vibrations of a black hole. Should we worry about the sun? Since our star hasn't reached its red giant stage yet, we can't know whether it'll turn into a cool red straggler. What we know, though, is that our star might contain those tiny black holes that formed in the Big Bang. But now, we have no means to check whether they're indeed there. Currently, our star is around the midpoint of its existence. Middle age, it creates energy non-stop by fusing hydrogen atoms within its core. Once it runs out of hydrogen in its core, it will enter its red giant phase and begin to collapse. It will happen in about 5 billion years, don't hold your breath, and the phase itself will last for 1 billion years or so before our star depletes its fusible materials and loses its outer layers. It will leave behind a tiny white dwarf star half as massive as the sun and around the size of our planet. In some cases, when the gravitational collapse of a star's core is complete, the stellar remnants turn into a black hole. But that's not the fate awaiting our sun. You see, our star just doesn't have what it takes to become a black hole. It's not heavy enough. There are a few conditions that can affect whether a star can turn into a black hole, including its composition, rotation, and the processes that lead to its evolution. But the main requirement is still the right mass. Stars with 20 to 25 times the mass of the sun can potentially experience the gravitational collapse needed to form black holes. In other words, the sun is simply too small to form a black hole. But what would happen to us if it did? You might assume that if the sun turned into a black hole, our planet would be doomed to be pulled into it. But do you remember the basics? Black holes aren't giant space vacuum cleaners, just sitting there and waiting for a new planet or star to get their hands on. Mwah! But black holes don't have enough gravitational force beyond that, created by their incredible mass. And if the sun were to turn into a black hole, which will not happen, this hole would still have the same mass as our former star. And Earth's orbit around this newly formed black hole wouldn't change. But all other things would change dramatically. The sun, which is currently around 695,036 kilometers in radius, would shrink to a mere 3 kilometers in radius. But you wouldn't be concerned with the absence of the bright yellow sphere in the sky, since you'd have many more pressing issues on your hands. Our planet's main heat source would be gone, leaving us frozen in the dark. Without this source of energy, photosynthesis would immediately stop, disrupting entire food chains. Eventually, all life on Earth would be extinguished. But rest assured, our hard, barren rock of a planet would continue in its orbit. Oh well.
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from 2 of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spherule beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spherule beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles, the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot